Hi, this is Mark Graban. This is a recorded practice session that I'm doing for the webinar that I will be presenting live on Monday, August 27th, 2018. The webinar is being hosted by my friends at Lean Frontiers. I recommend you check out their website, www.leanfrontiers.com. The title of my webinar is Improve Your Lean Management System with a Simple Chart. And it's based on concepts in my new book, which is titled Measures of Success: React Less, Lead Better, Improve More. So you can learn more about the book and find all sorts of resources, templates, other information at the book's website, www.measuresofsuccessbook.com. So let's get right into it. So when organizations talk about adopting, implementing, practicing a lean management system, I would argue there's two sides to this. There are the methods and the mindsets. The right methods with the wrong mindset might not give us anywhere near the results of an organization that really embraces the mindset. So methods might include things like this on the left. It's not an all-inclusive list, but we may have Kaizen boards, A3 problem solving. We may be practicing strategy deployment, and with that may come true north direction and performance measures, which is going to be one of the main themes of the webinar here. Now, it's possible to use any of these methods, maybe unfortunately, without using the mindsets that really make Lean or the Toyota production system effective, if not powerful. So these mindsets, again, not an all-encompassing list, but things like customer focus, respect for people, the idea that leaders are responsible to create a system in which people can be successful, and engaging everybody in scientific, systematic problem solving and improvement. And that's what my book is about, connecting performance measures to our improvement approach. And that's what I'm happy to be here talking about today. So within the context of a lean management system, I would try to make the case that it's important not just to have particular methods, but to also embrace a certain set of mindsets that really help us be successful using methods. And on the left-hand side, this is not an all-encompassing list, but the tactics or tools or methods that you might see used in the context of lean management: daily huddles, A3 problem solving, the executives practicing strategy deployment, which of course then includes true north, direction, and performance measures. And that's going to be one of the key themes for my talk today. But right away, you might be looking at these methods and say, well, wait a minute, there are mindsets here. And A3 problem solving is, of course, not just a template. There's a set of mindsets. And again, not a complete list here, but things like customer focus, respect for people, creating a system, leaders being responsible for creating a system in which people can be successful. And then, of course, engaging everybody in scientific, systematic problem solving and improvement. So within that lean management system, one goal, of course, is reducing waste. And this shouldn't be limited to a narrow view of looking at the value-added work done by the frontline staff. I think we can also take a look at what we might call management waste. What are the things that managers and leaders at different levels are doing that doesn't really help the organization make progress and move forward? We could call some of this management waste wasted motion. We could call it over-processing. And that's one thing I'm going to talk about here today: how we can reduce waste and better prioritize and focus that time in a way that leads to more improvement. So there's a really well-known quote. It's not, I wouldn't call it a lean quote per se. It's often attributed to all sorts of people, including the famed management author and professor Peter Drucker. And the quote says, or some variation of it says, "What gets measured gets managed." And in fact, the Drucker Institute, Peter Drucker passed away, but the Drucker Institute says he did not say this. So it's like some Deming quotes that get thrown around, or maybe there's Ono and Shingo quotes that maybe aren't real legitimate. But I think this idea has taken root in a lot of organizations. And I think there's way more discussion about the what gets measured part. What do we measure? What's our target? And I think a lot of organizations don't spend enough time thinking about the second part of this, gets managed. How do we manage? How do we improve processes that lead to better results? So in my travels and in different types of organizations, not just healthcare, there's a couple of really common practices that I'll propose don't really help us manage processes and prioritize improvement efforts. So I think one of the methods is, let's say, a whiteboard or some display that shows a single data point. So here's an example, a mock-up from a hospital or a clinic. So here's the percentage of urinalysis test results that are back prior to a patient appointment. There's a target of 75%. There's an actual number for a particular week at 66%. That's lower than the target. So sometimes it's colored in red. I wouldn't necessarily call that visual management. It's some form of visual indicator. But if you know numbers, 66, you know what direction the target's supposed to be, we can tell, all right, that week is not meeting the target. And sometimes we see, I've seen quite literally, smiley face or frowny face emojis attached to the metric, as if there's some people who are colorblind, red-green colorblind. So maybe that's where the emoji helps. But it makes me wonder sometimes, well, if a frowny face, actually inspires people to improve, can we up the emotion? Maybe we need some tears. Maybe we need to get, kind of spitting mad or red in the face angry. Well, I don't know if that really would count as a good example of managing a system. So if we look at a whiteboard or a single data point like this, we can ask, does this approach help us answer what I think are three key questions for any organization to ask about their metrics? The first question, are we achieving our target or goal? Well, the whiteboard with the color coding and the emoji magnet makes it clear that no, we're not achieving our target, but only for this week. There's not a lot of context to know if 66% is typical. Is that abnormally good? Is that abnormally bad? So there's a second question we need to ask. Are we improving? Single data point doesn't help. If we say 2 data points are not a trend, I think it's certainly true that 1 data point is not a trend. And then based on how the system is performing, how do we improve? Should we be reactive or should we step back and do more systematic problem solving? So if 1 data point isn't helpful, we see a lot of cases where people display lots of numbers. One of the first hospitals I ever worked with in the operating room, they posted something they called a surgical dashboard. And we see this big table of numbers, lots of months of data. But does this help us answer our 3 key questions? People, I think, are not good at seeing trends in tables of numbers. You're like, well, why was this called a dashboard? Has the person who called this a dashboard ever driven a car? Because a dashboard has a small number of very real-time metrics, like your speed. If you were to rush out and take delivery on a new Tesla Model 3, and here's its fancy-looking screen, it wouldn't be a very helpful dashboard if you're driving down the road and at 1:15 in the afternoon, you see this big table of numbers. What's my speed right now? Well, I don't know, but the dashboard shows me the hourly averages up through the 11 a.m. hour. Well, that's not a very effective dashboard, and I think we can do better than that in organizations. But sometimes the big table of numbers, again, has lots of red and green color coding. This is sometimes called a bowling chart or a bowler. I've heard somebody call it a watermelon chart because of the red and green, which, again, is great if you're not red-green colorblind. But if we look at a chart like this, we see lots of numbers. Can this easily help us answer our 3 key questions? Are we achieving our target or goal? Well, we see some green and some red. So the answer is, well, not always. Are we improving? Well, do we see more green to the right-hand side? Well, maybe there's more red, so are we not improving? Maybe the metrics are just fluctuating. And since we can't really determine if we're improving, what the trends are. It's hard to answer the question of how do we improve? Which of these data points, which of these numbers, if any, suggest that the system has changed significantly? I think the other additional question that's important, which of these merit reaction, investigation, or explanation? How do we prioritize root cause analysis, A3's improvement work? So we might ask, what would Toyota do? In the Toyota Way Fieldbook by Leiker and Meyer, it says at one point in the book that any improvement process should be driven by targets and then consistently measure and plot the measures on simple visual trend charts as discussed in chapter 14. So what they mean by a visual trend chart, I would call this a run chart. Now, even just a simple run chart like this helps us answer our three key questions to look for trends. Here we see we're never meeting our goal, and it looks like we might just be fluctuating. So again, from the book, there's a section that says, we need to look for the tendency. Is the problem getting worse, improving, or staying the same? We need to consider whether every problem should be addressed. So when we're looking at our metrics and trying to decide what to focus on, I think one important point to recognize is that there is variation in every metric. The question is how much variation is routine? It's impossible to answer this from a single data point, a bowling chart with or without color coding. If we look at metrics in our own personal life, here's metrics. If you say, well, my organization doesn't have metrics, you can track things like your body weight. Here's a chart of mine from a period of my life when my weight was relatively stable, but you know what? It fluctuates. Your weight is not the same every single day. The amount of time it takes to drive to work. My Fitbit measures my average resting heart rate on a daily basis. That chart, that metric fluctuates as well. So to figure out what variation is routine and when we have exceptional variation, we need to learn to see the difference between signals and noise. And I've learned so much in my career, and a lot of what's in my book is based on the work of Donald Wheeler and his great book, among other books of his, Understanding Variation, The Key to Managing Chaos. And I was really thrilled and honored when Dr. Wheeler agreed to write the foreword for my book, Measures of Success. So as Dr. Wheeler says, well, every data set contains noise. Some data sets may contain signals. Therefore, before you can detect a signal within any given data set, you must first filter out the noise. How do we do that? Thankfully, we have a tool and a method called process behavior charts, a form of statistical process control, or what you might call control charts. For those of you who really know this methodology well, it's called control charts for individual, and that's really getting deep into the detail here. But I think this is a method that a lot of people just haven't been exposed to. I think it's something that should be part of a core approach to lean management. And I think a lot of people just haven't been exposed to this. So if this is new to you, I hope this inspires you to maybe try a different way of looking at and managing your metrics and improvement. So I've written a book about how to use process behavior charts. You probably wouldn't be surprised to know I've looked at charts of daily book sales. So we can start off with a run chart, and let's turn this into a process behavior chart. So here's a daily run chart. The book launched officially on August 4th. So some of the days before that date are the number of pre-orders that came in through Amazon and their Kindle store. So the first thing we do to turn it from a run chart into a process behavior chart, or what's sometimes called an X chart that plots the data. Today, for those of you who really know this methodology, I'm going to ignore what's called the MR chart or the moving range chart, but I do address that in the book. So we calculate the average number of book sales, and we draw this line on the chart. Well, now I look at it and say, well, gosh, about half the days maybe are above average sales and half the days are below average. This methodology has taught me to not overreact to every up and down in the metric. So to really focus in on whether we've got signal or noise, we calculate and draw in something that are called the lower and upper natural process limits. So if you go and look at the formulas, and I talk through this in the book. You calculate these limits based on the inherent variation, in this case, day to day, in my metric. So the process limits are not what I want sales to be. This is what we call the voice of the process. And normally these limits would be symmetrical, but since I can't, I guess I could have a bunch of returns. I don't think Amazon will show a negative number of sales on a day. I hope that never happens. So the lower limit gets limited to 0. But the lesson from process behavior charts, plotting the data, calculating these limits, which is simple arithmetic, it's not calculus, I would determine that all of these data points are what we would call noise in the system. None of these data points in and of themselves are worth reacting to. This is what we would call a predictable metric. Now, we might not be happy with the range of variation or the average, but what this chart tells me is that going forward, unless something changes in the system, I'm going to have between about 0 and 18 book sales every day. So as I add a couple of data points, look what happened here. I had not 1, but 2 consecutive data points above that upper natural process limit. That tells me that, well, for one, we would call this a signal. This is a good time to ask what changed. Now, our process behavior chart will tell you that something changed. It won't tell you necessarily what changed. So in a lot of workplaces, this is where we would go to the Gemba. We would start investigating, talking to people, looking at the process. Here, I don't know. I wish I did. So maybe that will become clear at some point. But clearly, something has changed. And I don't know yet if this is a temporary blip upward in sales, or if sales are now going to start fluctuating around a new higher average. So there's really 3 main rules for finding a signal. Let me illustrate this using a different data set. What we might call rule 1 is looking for any data point outside of the upper and lower limits. Rule 2 is looking for a run of 8 or more consecutive data points that are above or below the average. This might be indicative of a shift in the performance of our system and our results. And again, it's appropriate here to ask what changed, what happened. And there's a third rule, looking for a cluster of 3 in a row or 3 out of 4 data points that are closer to one of the limits than they are to the average. Process behavior charts help us answer our 3 key questions far better than a table of numbers. Are we achieving our target? Are we improving? How do we improve? So if we take the bowling chart and visualize it as run charts, let's see if we can better answer these questions. So we take these six metrics from the bowling chart, and here's the first 3. So we see, well, they vary. Sometimes there's 0 patient harm events, sometimes there's 1 or 2, and that's bad. But we want to look and see, well, how do we react to each of those data points? Or do we react? Or do we improve the system? Here's the bottom 3 metrics. And again, we see there's fluctuation up and down. I don't know about that last one. So we have this question of, when do we react? When do we investigate? When do we do immediate reactive problem solving? So when we visualize these bowling charts as process behavior charts, or PBCs, I think this paints a very different picture. We've got in the lower right, if your intuition said that looked like a big jump down, you're right. So that was a metric that had a relatively narrow range of variation. And now we had actually 2 data points. One was just barely below the lower limit. One is quite far below the limit. So we have a signal that something has changed and it's worth investigating. So in this case, I think the hospital would really be well served by reacting to that first data point that's just below the limit, to maybe identify what has changed, what countermeasures, what can we do to put performance back where it was, if not better, before performance really dropped significantly in September. The 4 charts on the left all really just illustrate noise. So again, we don't need to accept any of this performance, but when we have a system that is nothing but noise, we're not going to solve any of these by asking, well, why was that data point good? Or why was that data point bad? We can step back and choose to improve the system by, again, I would propose within the context of lean that A3 problem solving is a systematic, less reactive way of understanding, analyzing, and improving the system. And I found a lot of organizations do nothing but react, essentially, to individual data points. Even if they are drawing charts, we need to distinguish the difference between signal and noise. When we react to everything the same way, we end up wasting time. When we ask for an explanation for every below average data point, that's not a good use of anybody's time. So in this, and actually we had signals in the upper right chart. So if we were to prioritize our efforts in the context of limited time, I would argue these two charts on the right are the ones we would focus on first. So from a reactive problem-solving standpoint. And then we can work on boosting the performance of any of these that are not meeting goals. So you'll notice on these charts, there are no goals. That's the last thing I'm going to cover here in the webinar, is looking at the two dimensions here. We're looking at process predictability. But then we can also look at what could be called process capability. Is our process capable of producing results that are better than the target? So to expand upon our three key questions. Question one, are we achieving our target or goal? We can ask, well, are we doing so occasionally or are we doing so consistently? I'm going to show you some charts that illustrate these situations. Question two, are we improving? As Toyota put it, or as it's put in the Toyota Way Fieldbook, what's the tendency of the metric? And can we predict future performance? This can be beneficial. We might not like the level of performance, but if we know it's predictable, that helps us answer question number three. How do we improve? When do we react? When do we step back and improve the system? And how will we know if we've improved? So let's take a look back at the trend chart or the run chart from the Toyota Way Fieldbook. So we see it's not hitting the goal, the production goal of an average of 36 per hour. When we calculate our upper and lower limits and we calculate the average, we see, I think more clearly, well, this metric's just fluctuating. And the upper limit of the predictable range of performance here just happens to be almost exactly the target. So that tells me, unless we make significant changes to the underlying system that generates these results, we will never exceed our target. So as leaders, I think the one lesson here is not to put pressure on people to just try harder, do better. They can't perform outside the bounds of the system that they're working within. So that's back to the Toyota idea of leaders are responsible for designing a system in which people can be successful. So and then we can work together to continuously improve a capable system. So let's go back and look at our bowling charts as process behavior charts with red-green color coding, as a lot of organizations will do on charts like this. I'll see run charts with red-green color coding. So now we look and see, well, again, we've got signals and we've got noise. The metric, the percentage of people who would recommend that hospital, you can see that one's designed to fluctuate. Well, maybe both of the two lower ones to the left are designed where occasionally we'll get some green data points because it's going to fluctuate within those predictable limits. So we shouldn't get too excited about the green because the same system that some months delivers red in some other months is going to deliver green. So we want to avoid these cycles of getting overly excited, smiley face, frowny face, good job, try harder kind of cycles. We want to respond to signals, and we want to try to boost the average performance of these systems that are predictable but not capable. And then here, when we look at these metrics, we're not reacting because they're red. Here, the average was actually really close to the target. It's harder to see at this scale. We want to react when it's red, or when it's a signal below the lower limit, or our other two signals, not just reacting when it's red. Reacting when it's red might be too late, as I'll show you in another example here soon. So here's an example of a metric that is unpredictable, because we can see signals. You might call this process out of control, and it's not meeting the target. The upper limit happens to be, again, coincidentally close to the target. And when we look at those individual data points above the upper limit, that's a good time to ask, what was different? Was there an improvement that we didn't really capture and turn into standardized work? Same thing about those low data points, to ask what happened and try to stabilize the system, asking for root cause for those signals, and both kind of continuing the good and improving upon the bad will probably also boost the average level of performance. Well, here's a system that's predictable and not meeting target. What we need to do here is improve the system. We could use an A3. We can be systematic instead of reactive. Over time, we may end up in this situation where it's a predictable system and it always meets the target. So this is really kind of the best possible situation. The lower limit is higher than the target. Unless something changes in the system, I can be pretty confident that it's going to continue fluctuating around that average of about 89%. And we can ask ourselves, well, still, do we need to improve the system? Is there a reason for the customer or for the business to boost that target? Here's a different system in a metric where it's predictable and the average is right about near the target. So again, we're going to have points in the green, points in the red, points above average, points below average. So one of the keys here is to not overreact to any data point that's noise. Instead, focus our effort on improving the system. So when we look at shifting performance into the green, here's a metric from that bowling chart where it dropped down below the lower limit, really deep into the red. The cause of that was eliminated, other process improvements were made, and now we see a system where the average level of performance has been boosted. The lower limit is right about near the target. This is a system that is now predictably capable of meeting the target. And then it begs the question of, well, should our goal or should our target be higher? And when we have a system that's predictable in the green, as we see here, we've got two signals. Now, a lot of organizations, if it's the binary, green is good, red is bad, they wouldn't react to any of these green data points because it's better than the metric. But there's two lost opportunities for learning and improvement. One is the signal above the upper limit. We should understand what was different there. Is that repeatable? Can that be turned into standardized work? Or was it just a fluke? And then for this other data point, we want to react and ask what changed. While it's in the green, it's below the lower limit. That's our trigger of investigation as one of our three rules. And we want to restore performance and improve before it dips down into the red. So to wrap up here, and again, for people who place value in this, I do, maybe you do too, what would Toyota do? I remember years ago, I visited, it was my first tour of the Toyota plant in San Antonio. One of the people in our group was actually a Six Sigma Master Black Belt, or maybe he was a Lean Sigma Master Black Belt. And he asked our tour guide, who had been a team member, does Toyota use Six Sigma? The team member answered, well, no, but we do teach everybody the 7 basic QI tools, which actually date back to the total quality management or TQM era. One of those 7 basic QI tools, as she pointed out, is control charts. That this is something that's used at Toyota, maybe not 100% consistently or universally. I've talked to a lot of former Toyota people, other authors and consultants who say, yeah, we use this idea, as Don Wheeler called it, of understanding variation to help prioritize and focus improvement activity. Because when we do so, and I've seen this in a lot of organizations, I'd love to see you try it and tell me if the same happens for you. When we react less and lead better, we can improve more. That's really the purpose of process behavior charts. It's not to have charts that look good and are technically correct. It's a tool and a mindset that helps us improve. So if you have questions, you can email me. You can contact me on the web. You can go to the book's website, www.measuresofsuccessbook.com. So again, this has been Mark Graban. I hope you enjoyed the webinar and found it useful. Please do check out the book, and I would love to hear if you have any questions about it, or better yet, what you're doing to implement or practice these methods in your organization. And again, thanks to the good people at Lean Frontiers for hosting the webinar. You can go to www.leanfrontiers.com.